Hello friend, I am Naval. You are watching Code with Naval. Welcome to Java series part 82. In the last video we saw iterable and collection interface. In this video we are going to discuss about a list interface. In this diagram you can see list, queue, set. These three are a child interface of collection interface, and ArrayList, LinkList, stack, vector. These four classes are a list interface implementation classes. Okay, so let's discuss list interface. List interface introduced in a Java 1.2 version. It has the implementation class ArrayList, LinkList, and two legacy class vector, stack. So what is meant by legacy class? Legacy class introduced in an old version, and these classes are old classes. That's why we can say these classes are a legacy class. List interface and their child classes present inside a Java.util package. There are few key points we have to know about list interface. Okay, so list store element in an insertion order. Whatever we insert order, in that same order list store element, and we can store a duplicate and null value in a list. There is no restriction anything like we can't store a duplicate, we can't store a null. We can happily store a duplicate and null value inside a list interface. List follow index based method to insert, update, delete and search the element. So if you want to add any element, if you want to delete any element, then we can simply pass index value and we can simply delete that element. We can simply add that element, and internally also list use a index mechanism. Okay, so here you can see these few classes, few implementation classes: ArrayList, LinkList, and these two legacy classes, vector, stack. So let's discuss one by one. First we discuss ArrayList class. This ArrayList is an implementation of list interface. Okay, ArrayList class implemented list interface. It provides a dynamic array to store element. So what do you mean by dynamic array? It automatically grow. If we store 10 value, then automatically it's increase the size. Okay, it's dynamic array. That's why we call a dynamic array. ArrayList class follow insertion order. Okay, ArrayList also follow insertion order. In what order we store, only that order we get a data. Okay, this ArrayList is a not synchronized. That means ArrayList is a not thread safe class. We can multiple thread can access this ArrayList element at the same time. Multiple thread can access this ArrayList object at the same time. That's why ArrayList is a not thread safe. ArrayList implemented a random access interface, so we can access any element in a same speed. So what is meant by random access and what is meant by accessing any element in a same speed? Let's consider in a real life example. In a project we got a requirement. We have to store in a one list, we have to store 1 lakh record. Okay, we happily store those 1 lakh record. Then I need a record. I need a first index record. Okay, this first index record I got in a 1 second. Okay, and 10th index, 1000 index, and we can say 1 lakh index record also we got within a 1 second. Okay, here because the random access we got a retrieval speed, retrieval same speed. We can access any element in a same speed because random access. Because random access we can access any element in a same speed. Okay, for manipulation here data shifting, but for a manipulation here required a data shifting, not good for insert and delete element in a middle. But if our requirement is I want to add, if there is already 1 lakh record, then our requirement, our frequent requirement is our frequently requirement is adding a record in a middle. Okay, once we insert a 1 lakh record, then our frequent requirement is add record in a first index, add record in a 10th index, 1000th index. For that case here data here shift required. Here if we index, if we add index, you can see in this diagram here we have only 7 index, 0 to 6. Here we have only 7 element. Okay, in this case here I want to add some value in a third index. Okay, when I add a value in a third index, that third index already have some value. That value shift in a next index, next value shift in a next index, next value shift in a next index, and so on. Here we have only after third index, here we have only fourth value. That's why here only required a 4 shifting. Here 4 element shift. But if you have a 1 lakh record, and in that case if you add value in a first or second index, in that case there required so many shift operation, and so many shifting means it take a performance, it take a time. Okay, that's why if you have a frequent operation, if you have a frequent operation, add a value in a middle or delete value in a middle, then ArrayList is not good for that. If we add value, then also shift required. If we delete value, then also shifting is required here. Okay, that's why if our operation is delete and add middle, then don't use a ArrayList. Okay, here you can see in this example, here we can simply declare ArrayList in this way. ArrayList, we can pass we can create a generic programming, or we can create a non-generic. Okay, that's not the case. We can create a both. Here you can simply create an object and using add method. Here we first we add a null, then ram, then again null, then sham. That means we can add a duplicate value happily. And here we saw ArrayList is a dynamic array to store element. It's provided dynamic array to store element. So what it mean by dynamic array, and how it's increased, and what is the initial. Okay, let's see all this. Array list size. Okay, create in empty array. First, whenever you create empty array, with default, that empty array default initial capacity is a 10. Okay, once it reach its max capacity, a new array list will be created with a new capacity. And what is the new capacity? Whatever current capacity into 3 divided by 2 plus 1. It's a formula for a new capacity. ArrayList variable point with a new ArrayList and old ArrayList destroyed by garbage collection, because this process ArrayList slow. Okay, here you can see in this diagram, here first we create ArrayList. When we create an ArrayList, its a default capacity is a 10. We can happily store a 10 element. After, when we try to insert 11th element, that time it will create a new array list. Okay, first it will create a new array list, then it will copy all old array list data in a new array list. Okay, step 1, it will create a new array list. Step 2, it will copy all old array list data in a new array list, and then it will add that element, whatever 11th index element, then add that 11th index element. Okay, it will. And then after adding this new array list all record, then this al is a variable. This al pointing earlier, this al pointing this old array list. Okay, now here we create here internally create a new array list. This al point new array list, and this old array list destroyed by garbage collection. Okay, this process continuously happening. If every time it's reach its max capacity, then create a new array list, then old array list all data copy new array list, then insert that new element. After inserting that new element, this variable point this new array list, and this old array list destroyed by garbage collection. This process continuously happening if we continuously adding a record. But because that for this process it will take a time, because that we have to sacrifice performance. Okay, we can't expect good performance because all this process take a time. But we have one solution. If you know already we need to store 1000 record, we need to store 1 lakh record, then we can define array list size. Instead of increasing every time, we can define size. When we declare this array list object, when we create this array list object, only that time we can pass this size. Okay, and only the initial time, only the initial when we create an object, only that time it will create a bigger array. Okay, it will create a 1000 index array, and we can happily store 1000 value, 1000 element. After 1000 completion, then it will follow this current capacity, this formula. Okay, let's see what is the, what let's see this current capacity is a 10 into 3. Okay, divided by 2. Okay, that means 15 plus 1 16. Okay, in this formula, using only every time when create a new array list and destroyed old array list. Okay, so let's open Eclipse and let's see practically. I'll simply create one class. Okay, let's create here class name with part82, and here create a main method. Okay, I'll simply create a main method, and let's create a first we will simply create a default array list, default constructor array list. Let's see, and here we pass string al equal to new array list. Okay, we don't need this. Here you can see this one is a simple, this one is a default array list constructor. Okay, let's see, here we have a few more constructor. I'll simply press control space, and here you can see array list with collection, array list with collection. You can see this array list, this we have so many constructor. Okay, let's see this one accept initial capacity. We can simply pass here initial capacity 100, and it's not required every time to create a new array until to reach this 100. Once complete this 100 capacity, then it will internally create a new array, and it will point this al, that new array. Okay, new array list. Okay, let's see, here we have a, let's create this default first, and I'll simply store a few record al dot add. I'll simply store here a. Okay, a, then al dot add, here store b, then al dot add, here store again a. Okay, then al dot add, here store e. Okay, let's store here e, and let's save. You can see here we store 2 times a, and also try null. Is it possible? Okay, again I'll store 2 times null. Let's save this and run this. Okay, we didn't print. Okay, let's print system.out.println and print this al object. Okay, let's save and run. Here you can see a, b, a, e, null, null. In which order we insert? In the same order here we get in output. Okay, here that's why we can say array list follow insertion order. Okay, then let's check what inside array list class. Okay, let's check. I'll simply open declaration, and here we can check internal code. Okay, you can see here default capacity, initial default capacity, or we can say initial capacity is a 10. Then here you can see empty element data, something like this, and here array list, when array list, here you can see we can pass initial capacity, this constructor. You can see then we have this constructor. Okay, you can see this array list can hold any other collection. Okay, let's try this. I'll simply create one more array list, and here this one we create a non-generic. Okay, al1 equal to new array list. Okay, here you can see we can pass simply this array list. We will simply pass here al. Okay, and let's try to print this 𝗧𝗢𝗘𝗘 al1. Let's save and run this. Let's check output. You can see here initially when we create this array list, only that time we store other array list inside this array list. We can not store only just array list. We can store any collection object. We can store a list, we can store a set, any collection object. Here we can pass here any collection object and we can store, and we can simply add here also al1 dot add, and here we can add other thing. We can simply add here 1 because here this one we create a non-generic, that's why we can add here any data type value. Okay, you can see ABAE null null then 1 Okay, then here you can see array list with collection, then down to size, and so many contents present here. You can see if we check array list method, you can see here size is empty, contains what contains. Okay, here you can see here we have so many method. Here we have a size, here we have a is empty, then contains, then index of, then list index of, clone. All this method we can use. Add, we can add a value in a particular location, particular index location. We can remove any element. We can simply pass index value and we can remove that element. We can remove first, remove all this method. You can simply check all this method, and also here you get. Okay, I'll simply again show you. You can simply hover and open with declaration, and you can see all this author name, see collection, see list, linked list, vector. All these are class. These are this all these interfaces, and you can see this one introduced in a 1.2. Okay, and also you can read these notes and you can get more knowledge. Okay, for this video that's it. We will see next topic in the next video. Till that, bye bye.